Hello, everyone. Welcome to Stop Committing Your Secrets. Git hooks to the rescue. This presentation is part of Azure Spring Clean 2022. If you want to find out more information about that event and see all of the other sessions, azurespringclean.com is where you want to go. And I'm very happy to be part of this event presenting this to you. So I'm Dwayne McDaniel. I am the Developer Evangelist here at GitKraken. Talk more about them in a second. I live in Chicago. I've been doing tech in some capacity since about 2005. Been a developer evangelist in general since about 2015. And outside of tech, I do improv here in Chicago. I love knitting and crochet, karaoke, and just having fun with the community. I work for GitKraken, maker of legendary Git tools. We believe in making Git easy, safe, and powerful for all. GitKraken Client is a desktop app that gives you full visualization into your work, as well as a powerful CLI, giving you the ability to drag and drop various commits and branches to perform actions, start pull requests, and just manage your repo and workflows in ways that the CLI by itself simply won't allow you to. We also make GitLens, the most popular extension for VS Code. It unlocks the real potential of Git inside the code editor. Gives you line-by-line file blame and authorship information through GitLens, and a lot of superpowers that VS Code by itself simply doesn't provide. We also make Git Integration for Jira. If you're a Jira user, Git Integration for Jira can help provide a lot more information about your repositories, pull requests, the comment strings, all of that inside of Jira, making it easier to manage from a management perspective and from working with it as a developer. So you might be wondering, what is a Git talk doing at Azure Spring Clean? Well, the truth is we all use Git. That's a universal at this point. If you're a developer, you're most likely pushing code to Azure or AWS or Google Cloud product. And you're also storing that code out somewhere like GitHub or GitLab or Bitbucket. At the heart of all of these services are secrets, passwords, API keys, credentials, certificates, just whatever your system uses, you need a way to manage that. Now, these platforms all have a tool built in to help manage that. With Azure, for instance, it's Key Vault, a simple place to store and access all of your secrets in a safe, orderly manner. The problem, though, is that a lot of secrets make it outside of Key Vault and other secret management systems. GitGuardian released a report in 2020 that said they detected over 2 million secrets in public repos. And they detected that that number is growing year over year. I'll provide a link to that in the write-up for this talk as well, so you can go read that full report. It's a really interesting read. One of the things it said is that 85% of the secrets are found outside of the corporate control in the developer's personal repos, meaning that it probably accidentally ended up there from copying and pasting in the wrong place, or just someone made a public copy of the entire repo and pushed that for some reason. But they do point to that it's probably not malicious in most cases. They're not pointing to the fact that someone just took all of their secrets and put them out front, poorly hidden or disguised in a weird name file. That's probably not what's happening most of the time. You can have the most lockdown security in the world, like Fort Knox guarding all the gold. But if someone just leaves a key out, there's probably going to be a bad actor or attempts to get in and do something. So it's best not to leave those keys outside. It's also a good idea not to do something like this. This is, believe it or not, a shortcut. That's a pretty complicated lock system. And my guess is whatever's behind that door is somewhat valuable, but like pens or notepads or extra floppy disks or something. And the people who put up that sign thought, well, this stuff's valuable, but it's not as valuable as the time we're wasting getting into this door every time. So let's just put up a note. People can get in. It's still some form of security, not the best, but it's better than nothing. It's not a good idea, but people do this sort of stuff all the time. We do it as developers a lot. And this is kind of what that looks like. We will hard code secrets into our source code. And people have the best of intentions with this. People think, well, I'm just going to quickly test this endpoint. I'm quickly going to make sure these credentials are even correct before I go set them up inside of Key Vault or whatever secret manager you're using. The problem is that they end up staying there more times than we care to admit. This can be because you've put this secret in there, got distracted, got a ping on Slack, and you had to go deal with an emergency really quick. And you come back, you're no longer on line 9 in your code editor, you're on line 900, or you're in a different file altogether. And you just forget, hey, I needed to take that out because the whole thing's working and you're in a hurry. If we just said, hey, stop doing this, and everyone just embrace that best practice, we could end the talk right now. But unfortunately, the reality is that we need to deal with this growing number of secrets that get released out there into the world. Now, very quickly, let's remind you what Git's role is in all of this. Git is the source control management system that's taking snapshots of your work over time, and then it stacks those commits one on top of another. This is another issue of secrets getting released into the wild, is if you commit a secret and then you remember later, hey, I should take that secret out, and you take it out in a future commit, that commit that has the secret is still in the stack. It's something you can surgically remove, but it's kind of painful. Git itself also gives us the ability to time travel, to branch off into multiple parallel universes and really move reality pointers back and forth in time into different branches. So it can quickly get out of hand to, like, where did I bury that secret? If I was working in a feature branch that eventually got merged into production, did I remember to sanitize that feature branch that I was doing all my experimental work in? It adds to the complexity of places you need to check. So Git is really awesome at what it does, but Git by itself, being the stupid content tracker, as they initially called it, doesn't really give you any additional security or make your code less secure in and of itself. Like any other tool, it's how you use it. Now, one of the real benefits of Git is that it actually does have some built-in tools to help you out with your security needs. Git Ignore is the prime example that I think a lot of people first think of when they think of not accidentally putting something in Git. If you have a secrets.json or a .aws/credentials file or wherever else you just store your secrets locally, that's a great first step. And then you can just access it via code from those files and then tell git ignore those files completely. AWS actually will automatically create you a .aws folder at your home directory outside, hopefully outside of anything you're ever revisioning, to help minimize the chances you'll accidentally commit a secret that way. But git ignore is awesome at what it does for ignoring files and not adding those to the tracked file inventory. And if everyone just did this, again, we would be done with the talk. It would be a very short talk. But git ignore can't deal with we hard coded our secrets. Not to over harp this or talk about it too much, but it's something, again, we all do. We all are prone to do this from time to time. It's not a good thing. It's not a best practice, but the reality is we need a way to deal with this actual situation on the ground. The problem isn't even that we put the code in there, put the passphrase in there. It's that we put it in there and then pushed the repo. Just like if you mess up a semicolon in a PHP or JavaScript file, it's not good. It's not a good thing you did that, but you can fix it before you commit. If you put a hard code a secret into your code and you pull it out back out before you ever commit, you're probably going to have a good day. It's nothing really wrong with that. Again, just to test to make sure the endpoint's up or that the credential is correct in the first place. The real problem here is that you pushed it. So that's what we want to prevent. Now, like I said earlier, you can theoretically remove pushed secrets from a repository, but it's not easy. Surgically removing an individual commit from the stack isn't impossible. It's very straightforward. It's just a distraction. You don't want to get rid of the entire commit. You just want to surgically remove just the pieces that contained the secret. And it probably means you're going to have an entire conversation with your team that's going to be pretty uncomfortable. that, hey, by the way, I released all of our API keys. Time to rotate all of our security keys. That's not going to be a great day. Now, I put there at the bottom mentions of SolarLint and GitHub Advanced Security. These are awesome tools that do static code analysis that look for secrets. So they can help shorten that time that when if you do push a secret before it's detected. But again, you've already pushed it. So that's the real problem. We need to prevent that in the first place. What we really need is some kind of automation, something that will stop us from committing if a secret is detected. Git provides a way to do this. Shouldn't be too much of a surprise. I was going to talk about Git hooks given the name of this talk, but this is the secret to not just a lot of security automation, but a lot of automation, period. The way I like to think about it is building your own Rube Goldberg devices. Rube Goldberg was an artist who created all of these very elaborate setups that did pretty silly things, but the core of it is still the same. Do a thing, it triggers something else to happen. And that script might trigger something else to happen all the way through to a deployment. Eventually, Git hooks can help you with your CI/CD pipeline. But today we're going to focus on security. So let's keep talking about that. There are a lot of Git hooks available to you. In fact, Git gives you 17 hooks. If you want to go read more about Git hooks themselves, I highly recommend githooks.com by Matthew Hudson. He's done a lot of research and provided a lot of great examples of how you would use all of these hooks. But for our case, we're really interested in the 3 actions that happen before a commit happens. When you do a Git commit, it fires off these triggers of pre-commit, prepare commit message, and commit message. Those are 3 separate actions to Git working down in the plumbing in the Git CLI language that let you insert, well, whatever kind of script that you want. Now, if you look at the Git hooks folder in a repo, if you've run a Git init locally or that Git hooks file has not been modified by the author, if you clone down a repository, you will see 13 sample files, .sample files. These samples are meant to be just that, samples of how you could potentially use Git hooks. All of these examples were written by the Git team, and some of them were written by Linus himself, or at least inspired by his workflow. So if you're not super familiar with some of these, it's going to be a little confusing to like, what's going on? Now I get to learn Git rev parse to be able to use hooks. No, I'm here to tell you it's a lot simpler than that. It's just a script. And it doesn't even need to be bash. Just bash is the one that a lot of people use out there because it's a very common scripting language. I personally love it. So my examples are written in bash. This example is inspired by Edward Thompson, who authored a bit of code called git dad, which makes the substitution. If you accidentally type git dad, it will still do a git add for you because that's probably what you meant to type and tell you a dad joke in the terminal at the same time. Bring a little levity into our workflow. Why not? So I thought, all right, well, I'll just look at the code from that, borrow that curl to I can has dad joke. And now every time I write a commit message, Git will tell me a dad joke inside of my terminal. And you can see here the joke that it tells. But this is just an example to say you can do anything you can dream up that you can script, you can insert, and you can use any scripting language available to you on your local machine. Let's break down what we actually need for our solution to work. So before I commit, something should check my code for any hard-coded usernames and passwords, API keys, security certificates, and any other credentials I define. If any of those are there, let's throw an error and not make the commit. Sounds like a pretty good plan to me. So you can totally build this yourself. In fact, I would encourage everyone to experiment with what Git hooks make possible. With a little bit of scripting knowledge, you can make it look for all sorts of strings and cases and scenarios, then do some kind of action against it. In this case, I'm going to use git grep. Git grep is an extension of grep itself that only looks at the files that Git is tracking. So the syntax is a little simpler. With regular grep, you have to specify what files or folders you're trying to look through to find those key phrases. With git grep, it just automatically looks at all of the tracked files, making it a little bit simpler syntax. So in the first one, I'm looking for an exact string of password equals something or password equals asterisk. And in the second example there, I'm looking for And this is a little more complicated because it's using regular expression. Anything that's 20 characters long that contains all caps, letters, or numbers. That's what that means there. So if I have an example file that has some things in it that aren't supposed to be there, and I try my commit, well, first it tells me a dad joke, and then it says, hey, I've detected one of your patterns. Stop. It threw out my echo message, no hard code key, no hard code password, so I know what to go fix. Now you can do this all day. You can modify this to your needs, but then you're also on the hook for maintaining it, extending it, building it, supporting it. There's a lot of things to think about when you're building something like this out. Now, if it's a simple tool for you to use locally, I say go for it and try it. But if something you're going to try to share with the rest of your team, you probably want something a little more stable, a little more proven out there in the world. And that's where open source has you covered. Now, I'm going to give credit where credit's due. I know this is for Azure Spring Clean, but AWS Labs built a tool called Git-secrets. And just what it says on the box, it looks for secrets using Git and Git hooks. In fact, all of the example code that I just showed was borrowed from this repository. This is how they do it. This is a team that's already put together a package you can just download, install on your machine, install per repository to say, yes, Git-secrets needs to start checking this, tell it what secrets to register. I know this is a busy slide, but this is exactly their documentation. You register AWS, and then it looks for AWS keys, secret key assignments, AWS account ID assignments, and allows patterns, very importantly. So you can build in example keys, like it says there, and it will say, all right, that one's allowed. We'll let that one through, even though it matches the pattern. And you can look for credentials that you're storing somewhere else. Again, this is specific to AWS, but this handles the vast majority of their use cases. So AWS users can just drop it in and keep going. So what this looks like inside of your code base is it will go ahead and add those 3 Git hooks in there, commit message, pre-commit, and prepare commit message, the things that happen before the commit actually executes. It will provide in your configuration file the patterns that secrets is going to look for, and then it will add a line to each of those commit files that looks something like that on the right. And don't worry about if you don't understand the context of it exactly on the first read, but it is well written and it's pretty neat. In action, this looks pretty similar to the error message that you saw earlier. We try to run a commit and it detects, hey, this key isn't supposed to be here. This other key isn't supposed to be here. It matched one or more of my prohibited items and then gave me some suggestions on how I could go about fixing those things. In short, it says, hey, something's wrong. I'm not going to make this commit. And those are obviously fake keys. You can try to use those keys all day if you want, and they're not going to go to anything. And you're probably thinking, but we're at Azure Spring Clean. What about me? That's great for AWS users. Again, open source community has your back. There are multiple people out there who have extended Git-secrets to add additional providers like Google Cloud Product and Azure that add in the common patterns you're looking for. So all you have to do as a user is install Git-secrets per repository, and then add AWS or add Azure, depending on which repo you're looking at. It's also open source, so you can dig in and find out how it's doing what it does and extend it for any additional use cases you want. If you're deploying into an internal server environment that has its own set of passwords and keys, there's nothing to stop you from adding this additional safety step for any service you ever need to manage a secret for ever. So it's very, very powerful. Big shout out to M. Salem Code, who extended this for Azure. There are other people that did it, but this is the first one I could find. So in conclusion, thank you very much for your time on this. Do not hard code your secrets. If we can all just remember to never do that, we will stop having so many problems. However, that's not realistic to just tell you that and expect everyone's going to stop committing secrets. But if you do hard code secrets, don't commit them. make sure you're doing checks. And if you do put something into your code, remember to take it back out. Automation should be there to catch the times you forget. But I would highly recommend focusing on not doing those things in the first place. But automation is going to save you if you do forget. Open source is out there to help you, not just with this use case, with a lot of use cases out in the world. So don't ever hesitate to go find a piece of open source code that helps with a problem you're having, and then go look at the code and see, like, how is it doing that? What could I do to extend this to more fit my specific needs? And if it works really well for you, maybe think about sharing that back out with the rest of the open source world. Together as a community, we can make the world a lot safer and a lot better for everyone. So again, I'm Dwayne, work at GitKraken. And if you have any questions, hit me up on Twitter at MC Dwayne, and I'll be happy to answer any of them. Thanks so much and enjoy the rest of Azure Spring Clean.